Another wonderful math video by Miss Morell at Tamales High School. And this video is going to be talking about exponential equations. And we did start to look at exponential equations at the beginning of the year. And you might recall that exponential equations are when we have a pattern that is increasing, okay, at a very fast rate. Okay, so not a linear equation, which the red line, as you can see right here, would be a linear relationship, and we'll review that in a moment. But an exponential growth would be increasing at a very fast rate where we multiply by the same common number each time. The blue graph obviously is still increasing, but not as fast as the green. Now, I did mention exponential growth. We also could have, at the same token, we could have what's called exponential decay, where something is decreasing at a very fast rate. For example, you might remember I talked about when I first purchased my Mini Cooper, right? I first purchased it for around $21,000. And unfortunately, it depreciated. Notice I didn't say appreciate, which would mean it increased. It depreciated at an exponential rate. All right, so before we talk about how we can write the equation for an exponential model, let's go back and just review linear equations for a moment. So here I have a table of a linear relationship. So if it's linear, it means that it is increasing at a constant rate of change, also known as the slope, which means it's being added by the same number. So you might remember that when I'm looking here, I'm noticing when I go from here to here, that's an increase of 1. When I go from here to here, that's an increase of 1. And I go from here to here, that's an increase of 1. When I go from 4 to 6, so this right here, again, this is an increase of 1. Here's an increase of 1. Increase of 1. 4 to 6, that's an increase of 2. I go from 6 to 8. Okay, that's another increase of 2. And then I go from 8 to 10. That's another increase of 2. So far I'm definitely seeing a constant rate of change. Each time I go up by 1, my output is being increased by 2. But then I notice, well, wait a second. I go from 3 to 10. That's not an increase of 1. That's an increase of 7. But I go from 10 to 24. Notice that's an increase of 14. But you will see when I find my slope, which again is my change in y over change in x, I would do 14 divided by 7, that's 2. Notice 2 over 1, 2 over 1, 2 over 1. Every single time I have that same constant rate of change. So we could have gone back and, we didn't notice it jumped from 3 to 10. We could have done 4 to 12. We could have done 5 to 14. 6 to 16, and if we'd kept doing that, we would have gotten to that 10 out of 24. All right, so you might remember that a linear equation does have its own linear model, and that is, I'm going to make this a little bit bigger, and that is y equals mx plus b, where m is our constant rate of change, and b is our starting value. So where would be my slope? Again, my slope right here would be 2 over 1. That's going to be my slope. My starting value, that b, is going to be right here. So if I had to write that equation, I would go ahead and write y equals 2x plus 4. And then I would check it, right? I would just mentally check that with a couple of those points. So if I were to say put in a 1, I'm going to have 2 times 1, that's 2, plus 4, I'm going to get 6. If I were to put in 10, I would go 2 times 10, that's 20, plus 4, I get 24. So that equation works for that linear table. All right, we spent a lot of time doing that at the beginning, the first half of the year. Now, what about when I look at, I'm going to go ahead and just erase all of this. So what happens when I'm looking at an exponential equation? All right, so an exponential equation, I'm going to have, again, I've got a table here. But an exponential equation means it's not going to be adding by the same number, that would be linear, it's going to be multiplying by the same number. So I'm noticing here that I start at 0, my starting value is at 4, just like the table above, right? Just if I go back and look at this, same thing. But instead of adding by 2, we're actually multiplying by 2. So I'm multiplying by a 2. And I notice here again, I multiply by another 2. And I'm noticing that again, I'm multiplying by another 2. So what is my multiplier? In this situation, my multiplier is 2. What is my starting value? Well, when my input was at 0, I started at 4. So what's the equation that I can use to represent this exponential equation? I'm going to use y equals a times b to the x, where a is, so a right over here, I'm going to go ahead and write that. So my a is my starting value, and the b my b is the multiplier. Okay, so I have to be able to kind of look at different things, and my x, okay, is representing how many times it's been multiplied. Okay, so that's going to represent my exponential equation. Now, in this situation, I had a table, so I was able to find my multiplier by looking at the table. What happens though if I'm not given a table and I want to find the multiplier? So how do I find the multiplier? So if I have a table, I'm going to look at, right, and see, well, what number, is there a constant number that's being multiplied? So for again, if I go back and look at this table, I can see that 8 divided by 4 is 2, 16 divided by 8 is 2, 13 divided by 16 is 2. So I'm able to see what that multiplier is. But what if I was just told what what if I was told that I have an exponential growth pattern and it's increasing by, let's say, 50%. Okay, so if it's increasing by 50%, I'm going to go ahead and put, so 50% I know is equal to 0.50. So I wouldn't want to just say that the multiplier is 0.5, because think about that. If I multiplied, let's say I had 100 and I multiply that by 0.5, that's going to get me 50. That didn't increase by 50%, right? That actually went down. So if I'm increasing, if I'm having a growth, I have to do 100%. That's the amount that I started with, right? Think about it. If I say you got 100% on a test, you got 50 out of 50, or you got 20 out of 20. You got everything. So if it's going to increase by 50%, I have to go back and add that to my 100%. So I'm going to have 100% plus 50%. That's going to equal 150%, which I'm then going to change that into a decimal. I don't want to times by 150. I want to times by 150%, which means I would be timesing by 1.5. If I have a decay, let's say that it's decreasing by 50%. Well, that means I'm going to go back and take my 100% and I'm going to minus that 50%, which will get me 50%, which is going to end up being 0.50 as a decimal. Write an exponential equation when I am given a table. So to the left, I have a table right here. It looks like it's referring to years and money. So I'm going to first look at if it's indeed an exponential equation. So I'm noticing that from here to here, it's going up by 10. And then I notice from here to here, it goes up by, looks like 110 to 121. That's $11, right? So it's definitely not linear. It's not linear. So in order for me to see if it's exponential, I have to see, is there a number, a common multiplier that's being multiplied each time? So I can think of that two ways. I can think, well, 100 times what is 110? Definitely not a whole number. Or since I know that multiplying and division are inverse functions, I could actually do 110 divided by 100. So I'm going to do that. So I'd go to my Chromebook or my calculator. 110 divided by 100. So I'm doing right over here. I'm going to do that. 110, and I'm going to divide it by 100, and that is 1.1. Okay, so now I have to do that again just to see, well, what about is 121 divided by 110? Because this would mean that 1.1, that it's 100 times 1.1 gets me 110. So let me just check that again. So let me go ahead and see what's 121 divided by 110. And it looks like that's also 1.1. Okay, great. So then I'm going to check that again. So I'm going to do 133.1 divided by 121. And yes, I'm also getting 1.1. Sometimes when we are modeling exponential equations, they might not be exact, they might be very close. And that's okay because we might be modeling that data. But in this case, we are getting 1.1 each time. So the multiplier is 1.1. So I'm going to go over here and use my equation. It's going to be y equals a times b to the x. That's what I'm going to use. So I already know now, looking at my table, that here's the starting value. At time 0, there's $100. So that's going to be my a. And the multiplier we just said was 1.1. Now I don't have to use those grouping symbols. I could put a multiply in front of that. I'm just using the grouping symbols. I wouldn't want to just put, though, like up above, A is right next to B, because those are variables. So I now have numbers and I do want to use grouping symbols or put a multiplier symbol. Okay, and that's it. I'm done. There's my equation. So if somebody had asked me to now figure out how much money there will be in, say, 5 years, I could go back and put where x is, I could put 5, and I could get what that value would be. Okay, so that's it. All right, let's look at another problem. So next problem that I have right here is I have written down, I'm just going to go ahead and erase this. Okay. All right, so I have written down here, Kim decided to buy a pink Corvette for $12,000. Sadly, it depreciated 20% each year. So it looks like, again, in this problem, I am given that Kim, right, her starting value is $12,000, right? That's when she bought it. So I know my A. Sadly, it depreciates 20% each year. So that's going back what we looked at. How do I find the multiplier? This is going down. So my multiplier is going to have to be is going to be 100% minus that 20%. And that looks to be 80%. And then I want to write that as a decimal, so that's going to be 0.8. So each year, sadly, right, her Corvette is only going to be worth 80% of what she paid for it. So I want to be very careful I'm not using 20% as the multiplier. If I was doing that, then it would be, I'd be only getting 20%, okay, of what's left, and it's not actually the case. So I do now have my multiplier, it's 80%. So now I'm going to go ahead and again write that equation. So it will be y equals 12,000 times 0.8 to the x. All right, okay, let's look at a couple more problems real quick. I know this is a long video. You're all welcome to pause it at any time and come back to it. So let's look at another situation. What if I had a table again, and I didn't, I'm going to go ahead and do a horizontal table, and let's say I started, I had 1, and I'm starting with so I'm just kind of choosing right now a pretty simple one to look at. You've probably already figured out what is Miss Morrell multiplying by. It looks like I'm multiplying by, you guessed it, I'm multiplying by 2. So we already know the multiplier, right? It looks pretty simple. The multiplier is 2. If I were to put another one, okay, so I have the multiplier. The multiplier is 2. Again, how could I check that? I could go back and do 6 divided, right, by 3. And I would see that that's 2. 12 divided by 6, I could see that that's 2. And then, of course, the inverse of that, 3 times 2 is 6, 6 times 2 is 12. So we have the multiplier, but I don't have the starting value. So how am I going to find that starting value? Well, I'm going to have to continue that pattern one more time. So I would have to kind of go, well, I know that they don't have it here, kind of like when we had a sequence, right? I don't have that 0 value. So I could go ahead and actually put that. I could say, okay, well, let me just go back and kind of add that to the table. If that's 0, what would this have to be right here? Well, 3 divided by 3 would be 1, correct? Okay, so my starting value must be 1. Now, if this hadn't been 3, let's say I had started at 4 and I was doubling it. Well, then I would have to do 4 divided by 2, right, to find what that starting value is. So now that I have the starting value, I can go and write that equation. It's going to be y equals 1, which I could do 1 times 2 to the x, or I could just write that as 2 to the x. All right. Last thing I wanted to mention is I know on one of the pages you're given a couple of points and you're asked, in fact, I think it is on page 5 of the homework. Okay, so you are given 2 points. Think about those points. Just go ahead and think about putting those into, so for example, I'll just put, I think you have something like this. You might have like a point 0, 5, and you have a point, let's say 3, 9. Okay, so looking at those 2 points, I already have the starting value. It's right here. It's at 0, 5. What I need to find is what is that multiplier. So I'm going to let you think about that. We will come back to this when we talk in our Zoom meetings. Okay, so think about, you've already got the starting value. You just need to figure out what the multiplier is. All right.